So hopefully by this stage you've drawn a whole bunch of graphs, you've investigated which lines are perpendicular and which ones are parallel. Hopefully you've come up with some of these as sort of your conclusions. So basically, if two lines are parallel, their gradients must be equal. And what we say is the gradient of one, or the gradient of line 1, so we'll say m1, is equal to the gradient of line 2, and we say m2. I'll show you how we use that a little bit more in a problem. If you just pause for a moment. So let's have a look at this. So find a line parallel to y equals 2/3 x plus 7. So really, to find a line parallel, what we know is that the gradient must be equal. So a possible parallel line is y equal to same gradient, and really I can add or subtract any number I like. So I could say, okay, subtract 5. Okay, I could add 32 on 4. I could, take away decimal. It doesn't really matter, but that is one parallel line. Moving further along to a bit more of a complex situation, I've got this. Show that the lines 4x plus 5y equal 20 and y equal to negative 4/5 x plus 2 are parallel. So when I look at those two, it's not quite clear that they have the same gradient, so I have to do a little bit of work. So let's start with equation 1. 1 is 4x plus 5y is equal to 20. So before I can do anything, because I'm interested in gradient, I need to rearrange the equation. So keep my y's on this side for now. Move the 4x. I'm going to subtract 4x from both sides. Now I want to get y on its own, so I'm going to divide both sides by 5. So 20, take 4x, divided by 5. 20 divided by 5 is 4. Negative 4 divided by 5 is best written just as a fraction. So y is equal to 4, take 4/5 x. Now, this is equation 1. So the gradient in equation 1 is my gradient here, equal to negative 4/5. Looking at equation 2, we have y equals negative 4/5 x plus 2. Now in this situation, we've already got it in gradient intercept form, so it's really clear. My gradient is negative 4/5, so this is equation 2. So gradient 2 is equal to negative 4/5. So the final statement to really show or prove that they're parallel is we say m1 equals negative 4/5, which equals m2, therefore parallel lines. I guess at this point it's interesting to note that if for some reason when I worked out the second gradient of a line they were not equal, I would write something like, I would say, m1 equals negative 4/5, which does not equal m2, therefore not parallel. So I suppose that would happen, if I had a different equation in this position. So I guess that's good to pay attention to.